As Dave mentioned, what we're here to present is actually a new project, a new report that's been published this morning, really trying to move the understanding of life cycle analysis forward. I will admit that Ricardo Strategic Consulting and Jane did all of the work, so I'm here really just to sort of set the scene and then capture the nugget at the end. So when it gets to the detail in the panel session, if there's any technical questions, please ask Jane. But I think the key thing we wanted to do really was to sort of set the scene about life cycle analysis. And we've been doing this jointly, actually, for probably 8 or 9 years now with the low CVP. Very early on in our gestation, we realised that low carbon has to mean low carbon across the whole life of the vehicle. So there's a lot of focus, and a lot of focus of the technologies you'll see today are, of course, on zero carbon from the tailpipe, zero emission from the tailpipe. But actually, it's quite an interesting debate here when you shift that carbon to another place and try and store the energy in electric form, particularly in batteries, of course, suddenly the impact on the build of your vehicle and the embedded carbon in the vehicle in production actually becomes more significant. So we've been looking at this, and back in 2011, Ricardo and Low CV published a report preparing for life cycle measure, that was called. And even back then, we knew that the trajectory for long-term CO2 regulation on vehicles is likely to move to life cycle. I think, as Dave mentioned today, we've seen commitments from the European Parliament some years ago about them sending a message that life cycle will be on the table in the 2020s, 2030s, and they're putting their money where their mouth is and starting some very significant studies now on how a life cycle regulation might be evolved. We then followed that up in 2013 and published, alongside our annual conference in 2013, a report looking at the comparison of different technologies, including biofuels. And it's really important to start thinking about the renewable energy and the renewable fuels when you look at a life cycle, well-to-wheel and then a life cycle analysis. So that study that we published in 2013 with PE International really looked out to the 2030 timeframe and really tried to highlight that there's lots of different ways of approaching this low-carbon life cycle analysis. What's been happening over the last few years, of course, since 2013, is that the market and the transport arena has actually been changing. So we are seeing some radical shifts. Electrification clearly is the buzzword in propulsion at the moment, and of course grid decarbonisation. So we've got low carbon energy and electric vehicles, and that's a marriage made in heaven, of course, from an overall vehicle operational perspective in terms of its carbon and emissions impact. But it does present us with some challenges in terms of battery and energy storage. And that is leading to increased battery sizes and potentially even charging speeds. So we're now hearing next generation Nissan Leaf potentially with 60 kilowatt hours. We've already got things like Teslas with 100 kilowatt hours, discussions about trucks with 600-700 kilowatt hours of battery on board. Now those become very significant carbon sinks in terms of production, and they also then need 150, 200, even 350 kilowatt charging mechanisms. So is that actually the right trajectory? I think that's the question we wanted to ask. And do we need to think a little bit more widely than just the passenger car sector? Of course, we have also significant developments in renewable and sustainable fuels. So low carbon energy, low carbon electricity is clearly on the trajectory, and the pathway in the UK is really encouraging in terms of grid decarbonisation. But actually there are some very, very interesting developments in renewable liquid fuels, renewable gaseous fuels, and we need to factor that into it all. A lot of focus, of course, on lightweighting and on material innovation. I think you've seen some of that during the sessions earlier today. But those lightweight materials potentially also have significant carbon impacts in terms of their production methods. Carbon fibre itself is not an easy thing to produce effectively. So that actually is a higher carbon life cycle basis than steels and things like that. I think one of the key aspects that we wanted to look at for low CVP, and that we really tasked the team at Ricardo to dig into, was the expanding range of vehicle categories. And by that I mean there's a lot of activity being focused on the passenger car, and clearly that's a lot of the focus of what you see out there today. But the L category, the micro vehicles, the motorcycles, that becomes a very interesting and different calculation if you start looking at life cycle, and Jane will touch on that a little bit. But also trucks. When we look at a truck doing potentially 1 million miles in its lifetime, what is the sensitivity to the production impact? What's the sensitivity to its operational impact, and indeed its recycling? So where are the sweet spots? Where are the sensitivities? And overlaying all of this over the longer term is the mobility habits. Currently, the model of buying a car, it being parked for 95% of the time and sat there on your drive or in your work parking place for the rest of the time, it's actually changing, and somehow sweating the assets that we build. If we have a high embedded carbon asset, we really need to sweat it to get the maximum out of it on a life cycle basis. And really, there was a lack of information around these aspects, which is what we wanted to dig into and try and create a bit of a better understanding to help inform the future debate and the future regulation. And I guess, if you like, summarising that, what we were wanting to do was to try and identify the role of having a carbon conscience, if I can put it that way, in the whole life cycle analysis. And importantly, part of our role as the low CVP is about bringing the community together, building the understanding so that the policies and the community and the industry can move forward in an educated and balanced way, rather than picking winners based on a narrow understanding of a particular subject. So I think that was really the background to what we were trying to set in terms of the stall and building the emphasis of our life cycle process. Our objective was to increase the understanding, help the community identify how to move this forward and how to think about life cycle going forward. One of our other objectives as low CVP is, how on earth do we explain this to a politician? And with all due respect to politicians, if there are any in the room, a picture kind of helps. So what we tried to do was to think about what's a simple way of illustrating the impact of life cycle and the impact of different technologies. So what we've looked at here is an example of the payback. So if we take our gasoline vehicle, we know how much embedded carbon is in that, and that's illustrated by the bar on the left. And then we also know how much carbon it will use, or it will generate, or contribute throughout its life. So, and that's a relationship to its fuel economy, of course. So you can see how the cumulative impact, the cumulative CO2 from that vehicle increases over its life up to potentially 170,000 kilometres. So if we now look at our battery vehicle, a typical 30 kilowatt hour battery, that's typical of a sort of vehicle, mid-range vehicle that's being sold today. There's a lot more embedded carbon in it, but the use phase is much, much slower. It's much, much lower gradient. And you can see that in that case, the vehicle will pay back. It'll be net beneficial in about 25,000 kilometres, so well inside its life. So as long as you're using your vehicle more than that. If we now start putting a 100 kilowatt hour battery into that same vehicle, that payback point shifts to upwards of 50,000, 60,000 kilometres. So if you don't use your vehicle very much, or you don't use it much over its lifetime, actually you might be better off with a gasoline vehicle in that application. If you're buying a very large battery vehicle and then only driving it 3,000, 4,000 kilometres a year for 10 or 14 years, actually you probably haven't done anything too beneficial. And that was a way of illustrating the impact and the importance of this embedded carbon in particular, which is hugely impacted by battery sizes, when we start talking about very low in-use carbon activity, such as an electric vehicle. And I think another way of illustrating this is the challenge we have in selling an electric vehicle to the market is very much the same as the impact on its life cycle. In the same way that your upfront cost of an electric vehicle is higher, but your in-use costs are significantly lower. So you have to look at it on a total cost of ownership, a total life cycle basis to identify the benefits. the same is true of its carbon impact as well. And I think that's a really important point. If we start thinking about infrastructure and very high power infrastructure, it gets another layer of complexity on top. So in applications where the embedded carbon is high, the reuse and the recycling also become very, very influential. That battery is a huge resource that if we can't then recycle it or reuse it, you've got a significant impact. If you can reuse it, or ideally recycle those into a new vehicle, suddenly you can reduce the impact of your new vehicle. I think when we look at very high energy use applications, such as a truck, actually a hybrid might be a better solution. Putting a 600 kilowatt hour battery into a truck is going to make a massive impact on its embedded carbon. And as we can see at the moment from the original table, the impact of a truck at the moment is relatively negligible in its production phase compared with its overall life. So we need to be really focusing on the low-hanging fruit of getting efficiency in its life. From my perspective, the demand by consumers for larger and larger batteries and higher power chargers could, if not considered properly in our policy environment, could be driving us down the wrong path in terms of overall impact. So my, if you like, plea, and the message we'll be taking back is that really right-sized batteries combined with a high-density range extender might actually be the right solution for many applications. And with the danger that I might be remembered for being the man that said bigger isn't always better, I think when it comes to batteries, it's definitely the case that bigger isn't necessarily always better. Thank you very much indeed.